Greetings. Welcome to our lecture series on mechanics of solid. In this prerequisite session, we'll be discussing about the types of supports. For a structural member, there are generally five types of support appears in existence: roller support, hinge support, fixed support, elastic support, and guided support. These supports defines the degrees of freedom of that structure and the force attracted or due to end restraints. Roller support. We represent the roller support by the sketch shown in the column number 3. It is shown by a geometry rolling over the rollers and a surface along which it is going to skate down. It indicates that the translational moment or displacement is allowed in the plane, whereas in the vertical direction it has been locked. So due to this end resistance, we can say there is generation of a normal force which is perpendicular to the plane here. Second case, hinge. Hinge is represented by the symbol given in the column number 2 here, which is represented by a triangular geometry shown with hatchings on the both the side. Means it is completely locked in respect to the translation moment. Means there is no translation moment allowed here in any of the direction, but it can have a rotational moment. So due to this fixity, there will be generation of two forces. One which will be the normal to the plane or normal to the your your restraint here support, and one will be the parallel to the support here. So we can say the reactive force Rx and Ry will be generated. In case of fixed support, the entire geometry has been locked. Neither the translation is allowed, neither the nor the rotation is allowed. Due to this, we can say there will be a generation of three force locking forces here. One is in x direction and one is in y direction, and a rotational moment x. The next type is the elastic supports. This is idealized with reference to a spring support, which allows a certain deformation depending upon the spring constant or stiffness of that spring. So here some sort of vertical translation is allowed, not complete, but some sort, means we can say partial deformation is allowed. That's why we can say the reactive force generated at this end will be the function of the deformable capability of this spring. The idealist example of this is the elastic foundation, that is the sleepers below the railway track. When train moves, we can find that sleepers are going to have a certain deformation action, it will act as a cushion which is moving up and down, giving the knocking soil towards the movement of the your train. The next one is the guided support. Name itself indicates that the rotation or displacement is being under a guided surfaces here. So guided surface, we have a smooth roller. There is no question about the generation of resistive forces. So it will be under the pull or push action with reference to direction the force is being applied. Let us have a real life example of this particular support system. So here the bridge deck is being supported by a hinge support, where this is completely fixed, the base plate is completely fixed and the roller is being there at the top, and it allows the your what we can say rotation over the surface here. Now the second one is a roller support here, where we can find that there is a rollers over the below the support system here. It's also an example of a bridge here. Now we can say fixed support, where the certain fixity is that neither the member is allowed to rotate or translate. So the example is here, where we can have a base plate connected with a bolted connection. Now elastic support, the example is here the bearing dampers, which are provided as a cushion between the pier cap and the deck slab of a bridge. These rubber plates are able to get squeezed up based on the load, thereby giving a certain deformation in vertical direction. Now we can have the system related to elastic. This should be referred as a guided support here. By mistaken, it is coming elastic here. Guided support. So we can find these plates are going to guide the rotation of this wheel. That's why we can name it as a guided support. Now there exist certain characters of the end conditions also. Like we can say the pin connection, semi-rigid connection, and rigid connection. Pin connection allows the rotation translation and it makes intact the particular member. It doesn't allow the member to have a separation. It allows the rotation. Like example, we have a pin support example like here. The pin which is provided at the ends of the support which allows the slight rotation along your truss here. Another example is the connection between the truck and its trolley, which is being executed with reference to the vertical pin inserted in the eye hole of the connections here, which allows the translation, and some sort we can find that the trolley is going to have a rotational actions. In semi-rigid connection, partially there is a clamping force applied. For example, a scissor. In scissor, we find that the two arms of the scissor is going to move in vertical direction, but they are not able to get separated from each other. This rotation is allowed, translation is allowed in one of the plane. Restricted translation also. Another example is towards a riveted connection. Next to that, we can have an example of bolted connection. Bolted connection, it also have a securing action, but it can be released up with reference to the applied force. So that's why we can say it is a partially or semi-rigid connection. Now we'll take an example of welded connection. Welded connection is said to be a completely locked connection which will not allow any type of translation or any type of rotation. It will fix the member in the position and it will not allow the member to move out. So these are the ways which we can provide the supports to the structure and resistance to the structure. Which more update I will come with such short videos in next lecture. Till then, goodbye. Be safe. Thank you.